We're going to go ahead and get started here. And we have a chat box as well as a questions box on the GoToWebinar. So feel free to chat or ask any questions as they come up throughout the presentation. And we'll either answer them as they're asked, or we'll wait till the end and we'll answer all of them then. My name is Errol Rankin. I'm a business systems analyst for SunWize Power and Battery, and today we're going to be talking about training for using our new PRE design tool for designing and ordering your own solar-powered system tailored to exact loads and site location solar resources. SunWize Power and Battery has been around for 20 years designing and manufacturing off-grid power systems with installations on 7 continents. We focus primarily on standalone PV, hybrid, and battery backup type systems. We're spread throughout the country with sales offices throughout, with manufacturing and warehousing primarily on the East Coast and the West Coast. Here are a few more of the additional services that we offer, such as sub-assemblies and kits, the capability to do UL 508A control panel assemblies, OEM integration, and much more. Things like installation services, training, system design and engineering, drawing packages are all things that are available through SunWize. So for the overview today, we're going to be starting to talk about what are Power Ready Express systems. Then we're going to talk about solar installation data, or Sun resources, and how that's used within the tool and what pieces of information are needed to utilize that. We'll talk about the specific site database used, and then we'll go over implementation and use of the design tool itself, including solar data and load calculations. So first of all, to explain the why for this tool, the primary purpose was to help customers streamline the process of designing and ordering off-grid power systems. This tool will allow you to get budgetary to exact system quote numbers in minutes rather than days or longer. It allows us to utilize modular control panel designs that minimize engineering and customization for every different type of system that we do. And then finally, utilizing input-output panels, which are separate side plates or back plates, where we can put additional power conversion equipment, customer equipment, or other devices to provide for a broader range of power solutions, including regulated DC loads, AC inverters, power over Ethernet, and much more. So to get started, if you want to follow along from our homepage, the 2 major menu areas that we're going to be exploring are under the Build a System dropdown, New System Design Tools, Build a Solar System, PRE Design Tool, and then this is going to be covering the Power Ready Express line, which is under Products, Complete Solar Systems, Power Ready Express. Again, here are the links to the various online design tools. Today, we're going to be talking about the PRE design tool for designing your own off-grid solar system. So what is a Power Ready Express system? Power Ready Express system is a complete off-grid standalone power system that provides continuous continuous power for loads 24 hours a day. It's comprised of the solar modules and the solar mounts, which together comprise the array. There's the pre-wired control panel, which includes the charge controller, circuit protection, wires, load distribution blocks, and anything else. You have the batteries for the energy storage and the battery enclosure, which contains all the power electronics and the battery. And then finally, we have our Power Ready Express input-output panels, and this is if additional power conversion equipment or features are required, then you can add any Power Ready Express I/O panel to any Power Ready Express system, assuming that there is fitment on the enclosures, and we'll talk about what those rules are in a little bit. So from a high level, a Power Ready Express system is a customizable system. We have the capability through speaking to a sales executive to mix and match any of the features and products listed that you see here. So that can be 12-volt solar modules or 24-volt solar modules. It can be an array size from 10 to 1200 watts. We can utilize a range of battery products and manufacturers depending on the need. Control panels have multiple options for PWM or MPPT charge controllers, and similarly we have a variety of mounting solutions including side of pole, top of pole, skid mount, etc. And then we have a variety of enclosure options as well depending on the exact battery fitment needs. So at the heart, our standard line of Power Ready Express systems are a select number of SKUs that are meant to cover the broad major size iterations that we offer within the Power Ready Express line. As you'll see, this matrix comprises loads that the system will support in amp hours per day. It maxes out at 155.4 amp hours per day in the highest solar resource zone. So in the top column here, we have solar resource values for your site, worst case winter month average. So if your worst case winter month average solar resources are between 5 and 5.5 sun hours, you would use the 5.0 column. And you would go down to the corresponding max load that you need and go over to choose the system in question. So here are some of the Power Ready Express I/O panels that we'll be talking about briefly, and some of the features that they enable base Power Ready Express systems to function with. We have both 12 and 24 volt 200 watt inverter accessory panels. So for any AC loads below 200 watts, you simply combine the Power Ready Express system with either your 12 or 24 volt Power Ready Express inverter panel, and now you have a complete system that will support any AC load under 200 watts. Similarly, for regulated DC voltages, for 12 and 24 volts, for any DC loads below 25 watts, simply combine the Power Ready accessory panel with the Power Ready Express system, and they're compatible plug and play. One common accessory that's frequently used is the 3-pole combiner for when utilizing multiple solar modules in a configuration that requires multiple strings to be combined. If you have questions on when a combiner box may be required, you can see our tech note at the top here on combiner box requirements. So we're going to briefly talk about solar insolation data and what it means and how it's utilized in the tool. Solar insolation data is a measurement of average solar daily radiation. It's expressed in units of kilowatt hours per meter squared per day. So if we have 3,000 watts of solar energy that lands on a square meter over the course of the day, then we call this 3 sun hours. When we're doing off-grid system design, we're usually only concerned in the worst month's average solar resources, which for us in North America is usually December. And the reason for this, if you're curious, you can refer to another one of our tech notes on solar sizing. The IEEE 1562 standard dictates for off-grid system design that the worst month solar average resource is used. For a quick map below, you can see general solar insolation values throughout the United States. In the Southwest, it ranges from 5 to 5.5 and up sun hours per day, down to 1 or less in the lowest solar resource areas. We strongly recommend that when finding or utilizing your own solar resource data to use what's called site data when possible, not extrapolated or satellite data. Site data means that the solar resource information was physically measured at a specific site, usually over a great length of time, as opposed to being a statistical model or based on satellite imagery, etc. This is an example of the sort of solar resource site distribution within the United States. This is for a 1991 to 2010 solar resource data set. As you can see, there is very good representation within the contiguous United States, so that in the vast majority of cases, it is possible to choose a representative and accurate solar resource number for your site simply by choosing the nearest city-state in a database lookup. For our tool, we have used the NREL Red Book, which is considered an excellent standard for solar resource databases. This database is a 30-year period between 1961 and 1990, so it's very extensive and thorough. We utilize the latitude plus 15 degree measurement, which I will go over in a second, for North American locations, because this is the most representative option for us to use for North America when designing off-grid solar systems. If you would like to download or review the full files for this site database, it's available at the link below, and it is publicly available information, and there have a single PDF file that covers the entire United States as well as state-based files. So for an example, this is out of the database itself. We're looking at Alamosa, Colorado, and you'll see here that on the second to bottom line, we have the latitude plus 15 degree row. If we go over to the right-hand side for December, you'll see that the average solar resource is 5.7 kilowatt hours per meter squared per day. So previewing ahead to the tool that we'll be using, you'll see that we have our city-state database lookup. And for Colorado, if you choose the Alamosa site, you'll see that 5.70 kilowatt hours per meter squared per day value. All right, so moving on to actually utilizing the PRE design tool, there are two major steps to the PRE design tool. The first major step is regarding the project site information or the solar resources for where the system is going to be installed. As I mentioned, the first option that you have is to utilize our built-in NREL Redbook city-state site database lookup. There are a variety of different sites for all 50 states. So there are several to choose from within every state. Simply choose the closest city to your project location and go from there. The second option that we have is for entering your own solar data. If you would like to look up the solar resources for your site, if you are doing a project that is outside the United States and does not have a site database location, or if you feel like you have more accurate information from specific data that you may only have access to, whatever your reason may be, we do have the option to simply enter your own solar installation data. Now, important that the solar installation data that's entered needs to be the worst month average sun hours. So again, if you're in the United States, typically that's going to be the average sun hours for the month of December. If you're in other locations throughout the world, that may be a different time period. So the second part of our tool is entering load information. The load information is basically the power consumption of the equipment that is going to be running off of the solar system. Again, we have two options for entering your load information. The first option is to use the load calculator which I'll talk about in a little bit here. We're going to demo that. That's a tool that we have within this online design tool that allows you to enter specific equipment information for up to 3 discrete devices. So we can enter voltage, runtime, current, wattage, etc. And we'll be going over that in a little bit here when we do the examples online. The other option, option B, is again, if you know your own load information and simply want to enter that, or if you've already done your calculations, you can simply enter your total average daily loads in amp hours per day. And that will be at either 12 or 24 volts nominal DC voltage. And I'm going to go back a couple of slides to explain the importance of the 12-24 volt distinction. All Power Ready Express systems are either wired at base 12 volt DC battery bank or 24 volt DC battery bank. So one of the design decisions that you have to make is whether or not you're choosing a 12 or a 24 volt system. At its most simplistic level, this is usually dictated by whatever your largest load is. So if you only have a single or multiple 24 volt loads, then you would definitely choose a 24 volt battery bank. If you have a single or multiple 12 volt DC loads, then you would obviously choose a 12 volt battery bank. If you have both 12 and 24 volt DC loads, then there are 2 important things to note. One is that typically you are going to choose to wire your battery bank voltage at whatever your largest load is. So if you have a 24 volt load at 100 watts and a 12 volt load at 10 watts, you're typically going to choose to wire your battery bank at 24 volts. The reason for that is because you want to minimize the efficiency losses for any conversion equipment that's required, such as AC inverters or DC-DC converters. So that brings me to the next point, moving on, is that we also have a tech note on understanding loads that goes through a variety of examples, including power conversion and how to combine multiple discrete loads together to find your total daily load. This is available under our tech notes section and can be used in a variety of situations that can allow you to bypass the limitation of the 3 discrete devices that are built into our load calculator on the online tool. If you have 5 or 10 pieces of equipment that you want to calculate, typically we'll do that in a spreadsheet and then calculate what the total amp hours per day are and then input that into the online tool. So once you have completed your site resource and your load information, you will go to the bottom of the tool and you will simply put in your confidence statement that you acknowledge that the above information is correct, and then you'll hit the submit button. Now, once you hit the submit button, if there is a valid system for your configuration, then you will be redirected to the web store that will have your dealer pricing if you are logged into your account, your SunWize Connect account. It will have the part number for the system that you need to order, as well as a description of the system and all the parts that are included, as well as your price. You can order it online through the web store 24 hours a day, anytime you want. You will get order acknowledgement and all the other associated information you would get by ordering any other products on SunWize Connect. Now, if you enter a system design option that does not have a supported managed system, you will see the following error that says, unfortunately, at this time, we do not have a standard system that meets those load criteria. In this case, for your project, a fully customizable Power Ready system may be required, and it has a link to our Power Ready systems. In those cases, we can do sort of unlimited customization and meet any loads that are perhaps larger than our limitation of 155 amp hours per day at either 12 or 24 volts. All right, so to give a quick summary here before we go into some examples, the PowerReady Express systems are complete standalone power systems for either AC or DC loads. Now, I will note that because the pole mounting size is typically dictated by the customer, and we may not have this information prior to the time that they decide to order online, we have made the conscious design decision to make the U-bolts a separate part for the system. So if you are purchasing a standard PowerReady Express system that is pole mountable, as most of ours are, then you would simply purchase the PowerReady Express 6-digit part number, as well as the sized U-bolts that you need for whatever diameter pole it will be mounted on. So if that's a 2-inch pole, a 3-inch pole, 3.5, 4, etc., you simply order the base system plus the U-bolts. Together, they will form a complete system to run any load at the nominal battery bank voltage in question. So either 12 volts DC or 24 volts DC. Now, if you are running loads that have AC requirements that are less than 200 watts, or regulated DC loads less than 25 watts, or a variety of several other features, we can meet those needs through our PRE I/O panels by simply adding another PowerReady accessory panel part number to your order. For loads that are over 200 watts AC or regulated DC loads that are over 25 watts, we would point our customers towards our fully customizable line of PowerReady systems, where, again, we do not have these limitations. For both of these cases, you'll note that there are efficiency losses due to these pieces of equipment, and you'll see when we get to the load calculator on the tool, we do have the capability to account for that. Now, for these systems, again, I want to reiterate that the total limit on the daily loads is less than 155 amp hours at 12 and 24 volts DC, and that is at the best solar resource level. So if you have loads that have a total daily requirement of over 155 amp hours per day, such as 200 amp hours per day, then that would be a PowerReady system, not a PowerReady Express system. So the goal here is to help our customers choose and order a correct solution specific to their site and load needs in minutes rather than days or longer. One important thing to note is that we do have the capability of making customization changes or tweaks to our baseline of PowerReady Express systems. So if you need to upgrade an enclosure to one size larger for extra space, or if you're wanting a different battery specification or module specification than the one listed, we can make those changes for you. So certainly encourage you to reach out to a sales staff and discuss what your options might be. All right, so I'm going to pause for a second and hopefully pull up our web tools here. And I want to encourage folks, if they have any specific examples that they would like me to run, to either put that into the chat box or the questions box, and I'd be happy to run through any numbers or examples that people would like to see. So while I wait for that, I am going to do two quick examples here to show if you already have this information penciled out for your project, such as what your solar resources are and what your loads are, how quickly it can be to find a system to get a quote for. So in the first example, I'm going to run a case at 3.7 sun hours and 25 amp hours per day. So in this case, I'm going to choose, I have my own solar data, and I'm going to input my solar resource value of 3.7 directly. And then I'm going to go down to the second section of entering your loads information. and I'm going to choose I know my total loads, and I'm going to simply enter 25 amp hours per day as my load value. I will hit confirm, and I will hit OK. And I will be directed to our web store, to the PowerReady Express system part number in question, 270313. I can see my dealer price, and I can see all my specifications. So I want to pause really quick and talk about why that is and how else you can see the same information. So going back to our PowerReady Express data sheet, you can see for the 12-volt systems here in question, I'm going to go to the sun hour columns first. And in our case, we did a sun hour value of 3.7. So we're always going to use the next lowest value because that is the limit. So we're going to go to the 3.5 sun hour column, and we're going to come down until we see our load in question of 25. So our max value here is 27.5 amp hours per day. So at 25, we would be expected to get this system, the 270313, and that is exactly the system that we went to on our web store. So this is the link between the matrix shown on our PowerReady Express datasheet, which is available as a handout on the presentation as well, and how those load and site informations are used in the tool lookup. So to do another quick example, if we were to enter our own solar data for a different example of 5.6 sun hours, and we know our load as 85 amp hours per day, we hit submit. You'll see it'll take us to 270318. Going back to the data sheet, looking at a sun zone of 5.6, the max column is 5.5. We go down to our max acceptable load limit of 87.9 amp hours per day. We've chosen 85. Go over to the left and you see our system in question is 270318. Again, what we've gotten here. So that's just showing how quickly you can get to a system quotation number if you already know your load and your site information. Now, if you don't know that and you want to use the site database lookup information, you choose Use City-State Lookup. We will choose Colorado if we want, and you'll see here's the options. We could choose Alamosa from the example, or we could choose something else such as Eagle. In this case, I'm going to go over a couple examples on the load calculator and show you how information for 3 discrete devices can be entered in to calculate what your total load is in amp hours per day. So for this case, I'm actually going to do 3 discrete loads. And you'll see that when we choose 3, it opens up all 3 different devices. So I'm going to call this device 1 radio, call this device 2 modem. I'll call this device 3 light. So you'll see we have several options for each discrete load. We can choose whether or not we want DC or AC voltage. If we choose AC voltage, you'll notice that it gives us a notice that tells us that any AC loads below 200 watts will require this PRE accessory panel. So you know when you go to order your system that you'll order a second part as well to go along with it to provide the AC loads. In this first example, I'm going to keep the battery bank voltage at 12 volts, and I'm going to set the first load to run 24 hours a day at 5 watts. So the device load for this, device 1, is 10 amp hours per day. Going to the device 2, I'm going to set this to run only 12 hours a day, and I'm going to make this 7.5 watts, again at 12 volts. And finally, for the light, I'm going to make this 24 volts, and I will let this run for 10 hours a day. And you'll note here that a conversion efficiency box has popped up. Now, the conversion efficiency only shows up when we're using a non-standard voltage. A non-standard voltage means that the load voltage is not the same as the battery bank voltage. When the load voltage is not the same as the battery bank voltage, a power conversion device is going to be required, either an AC inverter or a DC-DC converter. In this case, because it's a DC load, I am going to put in a conversion efficiency of 88% because that's the product that I'm planning on using for this. And I'm going to call the load 3.5 watts. This is a very small light. So you'll notice here at the bottom that we have another note. This one is now telling us that DC loads at non-battery bank voltages below 25 watts require a PRE accessory panel to operate, either a 12 to 24 volt converter or a 24 to 12 volt converter for regulated 12 and 24 volt loads. Now, in this case, reviewing what we have in here, we have one load at 10 amp hours per day and one load at 7.5 amp hours per day and one load at 3.31 amp hours per day. All summed up together, this gives us a total loads of 20.81 amp hours per day at a nominal battery bank voltage of 12 volts DC. So again, I'm going to hit confirm and then I'm going to hit submit. And it takes us to the system in question that meets our loads requirements. Now, I'm going to go back, do one more example. Use city-state lookup of Hawaii. Choose Hilo. Use the load calculator. I'm now going to make this a 24 volt load. Going to do 2 discrete devices. Call this pump. This is going to run 1 hour per day. And the load in question, we're going to set to amps rather than watts. So we're going to call this a 2 amp load. Well, let's call it a 5 amp load that runs 1 hour per day. And we're going to make this, let's actually make this an AC load, and we'll make this 1 amp. So you'll see that in this case, I'm going to redefine the conversion efficiency again to 91% because that's the inverter I plan on using. For the second device, we're going to call this another light. This one's going to run 18 hours per day, and we will do this at 24 volts DC. You'll note that when transitioning from 12 volts DC to 24 volt, the conversion efficiency goes away because we are now at our standard battery bank voltage. And I'm going to call this 25 watts. So reviewing our loads again, we have an AC load at 1 amp that runs 1 hour per day at 120 volts with a conversion efficiency of 91%. And we have a light with a 24 volt DC load of 25 watts that runs 18 hours a day. Here we have our total load summary. Hit confirm, hit submit. And now you'll see it links you to the appropriate 24-volt PowerReady Express system on our web store. Okay, one more example. I'm going to enter my own solar data. I'm going to put in a relatively low solar resource area of 2.0 sun hours. And I'm going to use the load calculator. We're going to call it 24 volts. And runtime 24 hours a day. DC voltage 24 volts. Amps. And we're going to choose 10 amps. So at 2.0 solar resources and 10 amp continuous load 24 hours a day at 24 volts DC, we'll hit confirm and I will hit submit. Now you'll see I basically get an error that says that you do not have a system. I put in a load of 240 amp hours per day, which is clearly over our limit of 155 amp hours per day. So correctly, it's telling us that we do not have a system. So if I go back, do one more test. If you enter your own solar data, note that there are limitations on acceptable solar ranges. So if you put in a solar resource value of 8.0, it will tell you to please choose a site between 1 and 7. If you choose an acceptable value between 1 and 7, you will see that the error goes away. If you put in an unacceptable value, you will see that there is no submit button available at the bottom. There is logic to prevent you from putting in a invalid entry with not enough information or incorrect information. So if you are seeing that the submit button is not showing up, then it's likely that you've entered a scenario that's not valid or doesn't make sense. So if we put in our correct sun resource value of 5, then you'll see the submit button all of a sudden shows up. Now similarly, if you put in a total load of 200 amp hours per day, you will get a similar error that prevents you from going forward. So I just want to point out those features for people that are using the tool in the future. So we've covered the 2 major steps, entering your project site info and the 2 ways that you can do that, as well as the second step of entering your loads info and the 2 different ways that you can do that. And we've briefly talked about setting your battery bank voltage to either 12 or 24 volt DC and what the guidelines are for typically making that choice. Again, on our website, the PowerReady Express landing page has links to the data sheet as well as any other information on our baseline systems. Under our drop-down here, you can choose any one in question and look at much more specifications and details on each individual system, including parts used and much more. So we've got a little bit of time left, and I want to see if there are any questions on the presentation today or if there are any other examples that folks would like me to run. We've got time left over if so. If not, then we can wrap up a little bit early and have people on their way. I saw somebody raise their hand. If you want to type your question into the chat box, I'd be happy to answer it, or I can potentially unmute you if you'd like to raise your hand again. Okay, well, if there are no other questions or comments, then my contact information is on the screen. Feel free to reach out directly if you have any questions afterwards. And otherwise, thank you very much, everybody, for joining.